All right, so in this video, we're going to be going over how to solve equations. And so as a part of that, first we're going to need to understand some basic properties and operations that go along with solving equations. Then we're going to briefly talk about unit conversions, because that's one of the applications of learning properties and operations. And then we're going to talk about simplifying expressions. And these are expressions that contain variables. And then finally, we're going to solve some equations for our variable. All right, so let's go ahead and jump right in and talk about different properties of equations. So the first properties we want to talk about are the commutative and the associative. So the commutative and the associative properties both apply to addition and multiplication. So let's go ahead and start out with the commutative property of addition. And so in words, what that means is in a sum, you can add the numbers in any order. So for example, if we had 3 plus 7, then the commutative property tells us that that is also going to be equal to 7 plus 3, because it doesn't matter which order these go in. You're going to get the same answer every time, which in this case would be 10. So as you can see, 10 equals 10, so therefore addition is commutative. Now, the commutative property of multiplication is very similar. It says that in a product, you can multiply the numbers in any order. So again, if we had 3 times 7, the commutative property tells us that that is going to be equal to 7 times 3. And this also works for negative numbers as well. So if we had negative 3 times 7, then that's going to be the same thing as 7 times negative 3. All right, so let's go ahead now and talk about the associative property of addition. So what that says is changing the grouping of numbers in a sum does not change the sum. So if we had 3 plus 7 plus 2, and these were grouped together right here, then that's going to be the same thing as 3 plus 7 plus 2, even if you did the 7 plus 2 first instead of the 3 plus 7 first. You're going to end up with the same answer. And that's very similar to the multiplication property for the associative property. It says changing the grouping of the numbers in a product does not change the product. So if we had 3 times 7 times 2, and we group these together and say we do the product of 3 and 7 first, and then times that by 2, that's going to be the same as doing 3 times the product of 7 times 2, where you did 7 times 2 first. So it doesn't matter which order you do this multiplication in or this addition in, you're going to end up with the same answer. So that's all those properties are telling you. So let's quickly talk about unit conversions. So unit conversions are important because you're going to need to be able to change units frequently when you're looking at different things in the world. So some basic things that you need to know about unit conversions are that there are 12 inches in 1 foot, 60 seconds in 1 minute, 60 minutes in 1 hour, 3 feet in 1 yard. And then if we're looking at the metric system, it's important to know that there's 1,000 meters in 1 kilometer. Which is also 10 cubed meters in 1 kilometer, or there's 10 to the negative 2 centimeters in 1 meter. So, with that in mind, if we wanted to say we've got 360 minutes and we want to know how many seconds and then how many hours. So we need to convert minutes to seconds. So what you're going to do is you're going to start with the thing that you know. So we've got 360 minutes. And then you're going to multiply it by a conversion factor. So again, we're going from minutes to seconds. So we're going to come up here and we're going to pick this one out here because it's got minutes and seconds in it. Now, when deciding which one you're going to put on top, minutes or seconds, and which one on bottom, what you want to do is you're going to want to line these up so that the minutes is on the bottom here, so it'll cancel out when you multiply it together. Because when you have a fraction, if you say you had 2 times 3 and 2 times 5, in a fraction like that, these here would cancel and you'd be left with this stuff here. So we want to create the same thing when we're multiplying for our unit conversions. So things on opposite sides of your fraction are going to cancel out. So since we've got minutes on the top here, we want to put minutes in the bottom here, which then leaves us with seconds. So we know there's 60 seconds in 1 minute. So you go ahead and you perform that operation. And you're going to get that there are 21,600 seconds in 360 minutes. So now if we want to convert 360 minutes to hours, we're going to do the same type of thing. So we're going to start with what we know. So we know we've got 360 minutes. And then we're going to multiply it by some conversion factor. So again, we're going minutes to hours. We're going to come up and pick the one that's got minutes and hours in it. So 60 minutes in 1 hour. And we come back here, we've got minutes in the top here. So we need minutes in the bottom here, and then hour in the top here, 60 minutes, 1 hour. These will cancel, you'll be left with hours as your units. So 360 divided by 60 is going to be 6 hours. And that's really all you need to remember for unit conversions. You just want to set it up so that your units are going to cancel. Now, say if we had 3,600 seconds and we wanted to get that to hours, you can do a two-step process for your unit conversion. So you just start with what you know. You're going to have to multiply it by something. So we're going seconds to hours. Now, we don't have one up here for seconds to hours, but we do have seconds to minutes and then minutes to hours. So we can go ahead and set up 2 conversions for that. So we're going to need 2 conversion factors. So in this first one, we've got seconds in the top. So we're going to go ahead and put seconds in the bottom here. And then we know that we're going to go to minutes. So these here are going to cancel. And then we've got minutes in the top here, so we need minutes in the bottom here, and then hours in the top. And then you can just go ahead and fill in your numbers. So there's 60 seconds in 1 minute, 60 minutes in 1 hour. Cancel out your units. Make sure you're left with what you want, and then you can go ahead and perform that operation. So 3,600 divided by 60, and then divide that by 60, and we're going to be left with 1 hour. So again, top and bottom of a fraction, they'll cancel, and you'll be left with your units that you want. All right, so now let's go ahead and talk a little bit about the distributive property. So the distributive property says that when you have some operation in parentheses, just say 3 plus 4, and that whole thing in parentheses is being multiplied by something else, you can actually distribute this multiplication to both of these and add those products together. So, for example, in this case, so if we've got 2 times the sum of 3 plus 4, then we're going to go ahead and we're going to have that product there. So 2 times 3 plus this product here, taking this sign with this value right there. So plus the product of 2 times 4. So we'd have 6 plus 8, which is equal to 14. And again, you can see that that distributive property works, because if we were to do the addition first, we'd have 2 times 3 plus 4 is 7. So 2 times 7 is 14. And these are the same. So the distributive property works. Now, if you have something like this, where you've got 2 times the quantity 4 minus 2, then again, you're just going to distribute here. So 2 times 4 plus 2 times negative 2. So 8 plus a negative 4, and you'll be left with 4. And again, if you had something like negative 2 times 2 minus 4, then you're just going to take this. So negative 2 times 2 plus this, which is negative 2 times a negative 4, because that second number includes the sign of your operation going on. So then you'd have negative 4 plus negative times a negative is a positive, so this is 8, and you'll be left with 4 as your quantity. So that's the distributive property. So now we're going to go ahead and look at simplifying expressions. So if we had something like this, where it's similar to what we had up here, but now we have a variable involved, we're going to go ahead and treat it the same way that we would as we did above. So again, you're going to come in here and do that operation there. So 3 times x plus that there, 3 times a positive 2. So 3 times x, you're just going to get 3x plus 3 times 2 is 6. And that would be the simplified form of that expression. So now say if we had something like if 3 times 4 minus x. Again, you're just going to distribute here. So negative 3 times 4 plus distribute here. You have negative 3 times a negative x, because remember to take this sign with you. So negative 12 plus negative times a negative is a positive, so you're going to have a positive 3x. And again, this would be your simplified form. All right, other things that you might see that you're going to have to simplify are going to be when you have multiple of something in the same expression. So for example, if you had 3 times x minus 2 plus 4x, and you're asked to simplify that expression, you're going to go ahead and you're going to start with this distribution right here and then worry about that last part after. So we're going to have 3 times x plus 3 times negative 2 plus 4x. So 3x minus 6 plus 4x. And now, when you get down to this point, you can actually combine terms that have similar variables attached to them. So these two terms both have an x term attached to them, so you can combine these. So we're going to have 3x plus 4x minus 6, which is going to be equal to 7x minus 6. Again, when you add these together, you just add their coefficients and then add on that x afterwards. So if we had something, for example, like 2x squared plus 4x minus 3xy plus x squared minus 1 plus 4xy. In this example, the terms that you could combine, You could combine this x squared with this 2x squared. And you could also combine this 4xy and this negative 3xy. So you would end up with 2x squared plus x squared plus 4x plus negative 3xy plus 4xy minus 1. So you'd end up with 3x squared plus 4x plus xy minus 1. And that would be your simplified form of that expression. Now that's a really complicated case, but I just wanted to demonstrate that you can't try to combine this x with this x squared because these variables are not the same. Even though they both have an x in them, this one is x to the first power, this is x to the second power, and so then therefore they are not the same and you cannot combine them. Same goes for this xy that is attached. You have to have variables that look exactly the same in order to combine their coefficients. So now that we know all those properties and all those operation rules, we can go ahead now and start solving equations. So an equation is going to be like an expression, except that it's going to have an equal sign. And we can use that then to help us solve for our variable. So for example, if we had x plus 4 equals 8, this means that when we solve for this x here, we need to find an x that makes this statement true. So what x could we plug in here to make this whole thing equal to 8? So for example, you could just go in and start guessing. So we could start with 1. So 1 plus 4 is 5. So that's false. So 1 is not a solution. Go plug in 2. 2 plus 4 is 6. So that's false. So 2 isn't the right answer. Plug in 3. 3 plus 4 is 7. So we're getting closer, but we're still not at 8. So 3 isn't the answer. We plug in 4. 4 plus 4 is 8. That one is true. So therefore we know that x has to equal to 4. Now, that's kind of a tedious way to solve these problems. So what we can do is use our basic arithmetic to help solve for x. So we've got x plus 4 equals 8. Now, when you have an equation like this, anything you do to the right side of the equation, you have to do to the left side of the equation. So for example, if we want to get x all alone on this side, we need to subtract 4 so that this way this goes to 0 and we're left with just x over here. So if we subtract 4 on the left side, we need to subtract 4 on the right side. And when we perform that, we're going to be left with x plus 0 equals 8 minus 4, which is 4. So x equals 4, which is what we got up here, but we got it in about half the time. So if we had x minus 4 equals 0, to get x all alone, we've got to get rid of that negative 4 right there. So we're going to go ahead and add 4 and then add 4. Perform that operation, x equals 4. X equals 4 is your answer to that. Now, that's addition and subtraction, so you always just want to do the opposite of what your sign is. So here to get x all alone, we had a plus 4 up here, so we're going to minus 4 below. And then, of course, apply that to both sides to keep it equal. So again, we had a negative 4 here, so we applied a positive 4 here and a positive 4 here. Now, if we look at something that has multiplication in it, we're going to go ahead and have, let's just say, 4x equals 16. So just like we did up here, how we were doing the opposite of what our operation was, we want to do the same with multiplication. So the opposite of multiplication is division. So we can go ahead and divide both sides by 4. These 4s are going to cancel. You'll be left with x on this side and then 16 divided by 4 on this side, which is 4. So again, x is going to equal 4 in this case. Now, if we did a division example where, let's say, we have x over 6 equals 2, and we need to solve for x, we have division over here where our x is. So to undo our division, we're going to do multiplication. So we're going to times this side by 6 and then times this side by 6. Because again, you got to do the operation to both sides. So these 6's are going to cancel. So you'll be left with x on this side and then 2 times 6 on the other side, which is 12. So x equals 12 in this case. And it's really as simple as that. So again, if you have addition, you want to do subtraction. If you have subtraction, you want to do addition. If you have multiplication, you want to do division. If you have division, you want to use multiplication. And then it's really important to remember to perform operation to both sides. Otherwise, you're going to get the wrong answer. So that's just a quick intro to solving equations and some properties that went behind solving these equations. If you have any further questions, you can head over to our homework help page or to our tutoring page, and we can sit down and go over one of these together.